whenever the state is changing, the component can automatically re-render. So we learned that yesterday, right? But we cannot rely on that component state infrastructure throughout our application. Why? Right? What is the limitations, and how do we overcome that limitation? Okay, so that is the agenda for today's session.
Sorry, a little bit late.
No problem. Okay, right. So what we will discuss is how do we manage the state. So yesterday our focus was on presentation. So how do you create a presentation? How do you make it interactive to the user? And today our focus is going to be on how to manage state. And as I said yesterday, the component has the state infrastructure using which you can manage the state, but that state infrastructure in the component has limitations, right? So what are those limitations and how do we overcome those limitations is what we will be discussing today. Okay, so we will first we will understand what are the limitations, and number two, we will overcome the limitations with uh, uh, our own model implementation and see how it helps us. And then we will see the drawbacks of our model implementation and look at how else we can manage the state for our application. Okay, so this is at a high level, this is the three main areas where we will discuss today, okay, which we will discuss today. Okay, so to demonstrate this idea, right, what I will do, I'll take a small problem as usual. We'll take a small problem, solve it, and in that we will learn the limitations of using the state, right, in the component state, and then we will see how we can overcome it with our own implementation. Okay, so it's not going to be a big uh, uh, problem. It is a very simple problem. So let's say I want to manage a list of products in my UI, right? I want to manage a list of products in my UI. Let me quickly create uh, uh, HTML. So, and one more thing, you may be wondering why I am writing everything in one single HTML page. Why am I not creating a proper application? Right? We will definitely do that. But the application as such is all about breaking your HTML file script code into individual files and then importing and exporting them. That's all. Okay, so there is nothing else nothing else we do there that will add value to our application. It is just breaking our code into small modules and then assembling them together by exporting and importing them. That is pretty much what all we do. So I don't want to focus time on that at this point of time because there are much more important things to gain clarity. All right. So, and moreover, for training, if we have everything in one single file, it is very easy for you to understand what code is changing, where it is changing, how it is changing, and why it is changing. Okay, so this is only for learning purpose. But when we build our application for real time, we will not follow this approach. We will create a proper application setup and then code in that particular application setup. Okay, so that is what we will do. All right, so let me create this application. So react.development.js and react-dom.development.js and babel.build.js. Okay, very good. And then I will have roots created and then script type equal to text/babel. Well, right, so we have the skeleton ready. Now, what is the component I want to create? This is the component I want to create. So h1 products plus hr plus a label and product name and input colon text, input colon button,
value equal to add new, and then plus OL li, and this let's say pen and li pencil. Okay, so this is the UI which I want to create, and let's create a component for this. So class products extends react dot component render, right? Turn, we will wrap it inside a div. There is a solution for this also. I'll explain it later. So we will wrap it inside a div, and then we will convert it into a proper JSX, right? So HTML for, and close this input, close this input. I think we are good now. And let us render this. So React DOM dot render the products, comma document dot get element by ID of the routes. Okay, very good. So this is where we want to render. So let me save this and open this page in the browser. So go to training products.html, drag and drop it. There you go. Right? It gets displayed. Okay, very good. But it is pretty static, right? We want it to be a little dynamic. So first of all, let's learn how to create this list dynamically, right? How do we create this list dynamically? Let's assume that the products are in a variable, right? So constant product names is equal to an array that has pen and pencil, and I want to create this LI items, right? Based on what we have here. I'm assuming that everyone knows the map method in array in JavaScript, right? So map can be used for transformation, converting one list into another list. If you don't understand this code that I'm going to write now, let me know, I'll explain. So here I can say product items is equal to product names dot map, take the one product name at a time, and return li that will have the product name slash li, right? That will have the product name slash li. And so now this is where I'm going to display the product items. So product items, this is where I'm going to display it. And now you still get the same output. I'm reloading this page. You still get the same output, but this is now dynamically generated. It is not static. It is dynamically generated. And how do I prove this? Very simple. Add one more item to the array and see if it displays it here. So let's go here and then say marker, save this, go to the browser, reload it. When I reload it, it displays pen, pencil, and marker, right? So it is displaying fine. Now, if you look at the console, there will be an error, right? Basically a warning, not an error, but a warning. What does the warning say? Each child in a list should have a unique key prop. So basically, when you are creating an array or a list of React elements, right? What does product items contain? Product items is nothing but an array. So console.dir of product items, right? So it is basically an array of React elements, right? It is basically an array of React elements. And when you create an array of React elements, React expects you to have a unique key prop for each of those elements so that it can optimize how it is rendered. And one approach that we can follow is you can use an index, right? You can use an index, and you can say key equal to index. Key equal to index. Save this, go to the browser, reload it. Now the error is gone, but this is not advisable. Okay, if you go through the documentation, you'll find that it says that don't use index for the key prop. The reason is once you assign a key for an item, the key should not change for that particular element. For that React element, the key should not change. Okay, but if the list is not changing, the key will not change.
But after you render the React component, if you remove the first item, let's say you render this, and so the key for the first one is 0, key for this one is 1, key for marker is 2, right? But now you at runtime, due to some business logic, you remove one item from the list. The pen goes away, right? When the first item goes away, automatically the index for the remaining items change. Pencil will become key become 0, and markers key become 1. So when you have that, when you do that, when the key changes, then you lose the benefit of having a key. Okay, so React advises not to use indexes. React advises you to use a value that doesn't change for that particular item, for that particular data. Okay, so when you are building a real-time application, when this data is coming from the server, right? This is served by an API from your own application or from a third-party service, and definitely you will have each of these data associated with unique IDs, right? So you can use those unique IDs as the key. Now, since we are constructing this in the browser itself for learning purpose, it is okay, right? We can use the key. So I'm going to use the key to avoid that particular warning to appear. Now save this, go to the browser, reload it, it displays pen pencil marker, and the warning doesn't appear anymore. Okay, very good. But then I want new products to be added. So every time I add, every time I enter the data in the text box and click the button, I want new products to be added. So how do I do that? Right? How do I do that? So obviously this data has to be in the state, right? This data has to be in the state. So copy this, paste it here. State is equal to an object where we have the product names with this particular array, right? I'm keeping them in the state, and then this is going to be this dot state. Take it from the state and use the destructuring syntax to take it from the state. Okay, and let's check if this is working. This is working perfectly fine. And let us check if this is taking the actual data from the state. So remove one item, it is taking the data from the state. Okay, very good. But then how will I take the data from the text box and keep it there? This is the usual stuff that we typically do. So we'll take this new product name, right? Is an empty string, and then I will have a method, or I can write it, yeah, right? On add new, as a matter of fact, yeah, on add new click equal to, and a method where I will simply say constant product names is equal to this dot state. Take it from there, and then product names comma new product name. Take both of them, and then here we will say product names dot push what the new product name, and then let's say this dot set state of product names is the product names. Okay, so I'm doing a set state so that it can be re-rendered, and populate the data, new product name. So on change is equal to, given the event object, you call this dot set state of new product name is the event dot target dot value, right? Event dot target dot value. Okay, give a function, and we expect that to be executed every time the text box is changing. Now let us check if this is working. So I'm going to keep the array as an empty array and save this. Go to the browser, reload it, and now let's say add new, not working. Why? Add new product name, product names dot push, new product name, this dot set state, product names is the product names, and on text change, this dot set state, new product name is event dot target dot value. I did not bind the event. So on click is equal to this dot on add new click. Okay, so I did not even bind the event, that's all. All right, so we have pen here,
we have pencil here, we have marker here, right? So I keep adding the list, adding new products, and it gets listed, right? Nothing complex, very, very simple. Very simple. Take this code, have a look at it, and then I'll give you a simple assignment. Okay. So let's say this is so products. The code is checked in. Take it, go through it, make sure you understand the code. Are we good? Okay. Now here is the problem for you. What is it? I want to display the products count. I want to display the products count, but not inside the products component. Right? I want to display the products count, not inside the products component, but somewhere out. Okay. So let's say this is our application. Right? So this is our application. This is the browser. And this is where we have the products component. And this is where we are and then we are displaying the list of products. Now, if I display any of the component is very
Manish, I think you're breaking.
outside here. The count displayed.
You're breaking up a little bit. Could you repeat what you're saying about the task?
What is it? Okay. So I was saying that
It's still breaking up quite a bit.
we display the count of products, right? Okay. No.
So is it cheating at this stage if we just ask Matthew to do it for us because he's the Fed? Can you do our homework, please?
Hi, is my audio better?
Yeah.
Yep.
Okay. All right. Thank you. Okay. So this is what I was showing. So this is our application, right? This is our application. So let me redraw this once again. So this is our application, and this is where we are displaying the products component, right? This is where we are displaying the product component, and we have the data entry text box, we have the button, etc. And this is where we are displaying the list of products. So as and when the user enters in the text box and clicks the button, we display the list of products. Okay. Now I know that we can display the products count. I want to display the count of products, the number of products. I want to display the number of products. And I know that it is very easy to display the number of products anywhere here, right? Anywhere here we can display. So as a matter of fact, let me do this straight away. So I'll do this. So I'll have a div and a span. Right, product names dot length. Okay, so I'm doing this. Now save this, go to the browser. So go to the browser, reload this. So I'm displaying count 0 here, and you say pen and pencil and whatever, it doesn't matter, okay? And say marker. Now the count reflects the number of products, no doubts about it. It works just fine, right? But what I want is, I don't want this to be a part of this component. I want this to be outside this component. The count should be displayed outside this component, right? So if this is our application, I am displaying the count right here itself. I am displaying the count right here itself, right? I don't want it to be displayed in the products component. I should be able to display it outside the products component. So maybe let's say I want to display it here, outside the products component, right? So what does it take to display the products count outside the products component? Can you attempt it? I'll check in the code, take this and try to change it in such a way that the count is displayed outside this component. Okay. Code is still waiting. Done. Code is checked in. Good. And let me know once you're done. Guys, please let me know once you're done. Okay, so Meets has done it. Let's give others a few more minutes. Pete has done it. Matthew has done it. Thank you. Others? Okay. Can one of you, Benny has also done it. Okay, good. Can one of you care to show us what you have done? Meets, you finished it first. Can you please, do you mind showing your code? I'm stopping my presentation so you can share it. Is it okay?
Yeah, it doesn't work, but yeah, I can. If you want to see a non-working version, that's fine.
Okay, so who has a working version? Joe? Okay, Pete, do you have it?
You like? 1 second. So I'm going to present.
Wait, I'll stop my presentation. Yeah.
Sorry,
Now
do you want to see the browser? Do you want to see the code? I guess. Yeah. Okay. I could probably do a screen. Maybe I'll share my screen. How about that? 1 second. While I map them out. Which screen am I going for? This one. There we go. So here it is. Hold on. Let me just reload it. Hopefully coming up on your screen. Here it is doing its thing. It should probably clear down, but it doesn't.
All right.
But there we go. Right.
And the solution is?
I just created a child component, whatever you call it. I passed it the count.
No.
I clicked the thing.
No,
so I misunderstand the task. Okay.
No. The product count has to be outside the product's component.
It is outside the component. It's in a different component.
No, you are using it inside. You are using it inside.
In that case, I misunderstood what you want me to do.
Right. So the count has to be used outside.
Oh, entirely outside. Oh, right. So you wanted me to stick it in state and pull it out into that from there.
No,
okay. I understood it to mean you wanted it in a different component, which is where it is, but it is then using that component inside the other component. Right. I misunderstood the task.
No problem. Okay. So let me show you what does it take to do this. Let me share my screen. Thanks, Pete. Okay. So this is what I meant. Okay. So just to clarify. So this is our application, and this is our products component, and this is where we are displaying the products. So this is the data entry screen, data entry part, and this is where we are displaying the products, right? And the products count has to be displayed out somewhere here. Anyway, it doesn't matter, but outside the products component. Okay, the products count has to be displayed outside the products component. So how do we do this? If I have to do this, then how will I implement it? So let us take this, make it as a products component, products count component. So class products count extends React dot component. You can create it as a functional component. No doubt, return this, right? Return this. Okay, but how will I get the count? This product count component will not have access to the length. Right, so this will not have access to the length. So how will it display? So that has to come as props. So let's take it as data, some data member, and the constant data is equal to this dot props, and then you display it here. Okay, very good. Now, when I want to keep both of them, right, products and as well as products count, I can have a div and display them. So you can have a div and you can display the products count, and you can display the div here, and this you can display the data. So data equal to something. Okay, so you can say 100, and that will automatically be displayed there. Let us check if this is working. Let's go to the browser, reload it. There you go. So the count is displayed here, and you type something, this gets added here. But we have to make the changes. We have the changes that we make in the products component, right, has to reflect in the products count component. So how do we do that? If we want to do that, then there has to be some way by which the data from the products component can reach the products count component, right? And in this case, they are siblings. So they cannot have any knowledge about each other. Products count cannot know anything about products. Products cannot know anything about products count, right? The only knowledge that they can have is what they receive from the parents, right? What they receive from the parent component. So this has to become a component. That the base has to become a component. So let us create it as an app component, and let's create class the app component and extends react dot component. Okay, very good. Render, and when I render this, I am going to return this. So I'm going to return a div, and that div is going to have these two. Okay, so slash div, and so now I am simply going to render only the app component, and that will automatically render the products count and as well as the products component. Okay, very good. Now how is it going to help? Introducing one more parent component, how is it going to help? This will help coordinate between the two components, right? Two siblings. How? What I can do? I can request the products component to let us know whenever a new product is added, or whenever the array is changing, whenever the products array is changing, right? I can request the product component to let us know whenever the array is changing, whenever the data is changing, right? How do we do that? Using a prop, right? So here I am going to write a method. I'll say on products change. On products change is a simple event, and I am expecting this to be invoked with the product names, right? I am expecting this to be invoked with the product names, and this I will retain it in the state. So state equal to whatever. Okay, so products is the empty array at this point of time, and every time we receive this, I'm simply going to call this dot set state of the products is the product names, right? So I'm receiving it and keep it in the state. And when I render the products count component, I'm going to pass this length. So this is going to be this dot state dot products dot length, right? This dot state dot products dot length. Okay, very good. But then this has to be given as a prop to the products component. So we'll send this as on list change, right? Or on change, whatever name that we want to have, we will have it. So on products change, and in the products component, we'll simply call this dot on props dot on change of what? The product names, right? So whatever we have, we will send it. Okay, very good. Now let's go here, reload it. This is displaying 0, and then let us add a pen. It is displaying 1, and pencil 2, and marker 3, right? So it is working perfectly fine. So if I have to show you a pictorial representation of what we have done, this is what we have done. So right,
So whenever the products component undergoes changes, the products component communicates to the parent component and say, boss, my state has changed. Right? The products component communicates to the parent component and say, my state has changed. And the parent component in turn sets its state. It is changing its own state, this dot set state, right? So in the parent component, we are calling this dot set state. Whenever we are receiving instruction, we call this dot set state, right? And when we do set state, what are we able to do? We are able to automatically render. It will render its presentation, and when it is rendering its presentation, we are rendering both the products count component and as well as the products component. So when you are rendering the products count component, you pass the length of the products, right? You pass the length of the products. So every time the products components state is changing, it has to call the parent component and say, hey boss, my list has changed, and the parent communicates state, and thereby it is able to pass that data to the products count component, right? So this we are able to do because both the products component and as well as products count component share same parent, which is the app component. Right? We use the parent component as a medium through which these two components share some state. These two components share some state. Am I making sense? Guys, are you with me?
Yep.
Right. I am checking in the code. Take this, have a look at it, and let me know if you have any questions. So what is this? Right. The code is checked in. Okay, very good. Now let us take this problem a little further, right? At this point of time, the products component and the products count component share the same parent, the app. So we are able to enable communication between these two. Through the app component, we are able to communicate. Okay, very good. But what if tomorrow your application requirement changes? So what is the change? The change is we have the main app component, and that component in turn has one more component, and that in turn has one more component, and here is where we want to display the count component. Okay, so this is where we want to display the count component, and then the main app component has one component, and that in turn has another component, and that in turn has another component, and this is where we are going to display the product list component. Okay, so nothing stops your user from asking where he wants to display the data, right?
So he might want to display the count in the same products component itself, or he might expect you to display the count somewhere, completely different part of the application, right? Now, the problem here is these two do not share the same parent. So now this and this do not share the same parent. But any changes that happen here has to reflect here, right? Now, what do we have to do? So if I follow the same approach that I implemented in our solution, if I follow the same approach, you know what we have to do? This component has to call its parent and say, hey boss, something has changed. And that component has to call its parent, that has to call its parent, which will in turn call its child, which will in turn call its child, and then finally the actual products count component will get to know about it, right? So there will be a very, very messy communication, callbacks, right? From one component to another component to another component, there will be too many callbacks that will have to go in this particular direction, right? From this component to the parent component in this direction, there has to be too many callbacks if you want the state changes of one component to be reflected in other parts of the application. Now, don't mistake me. If the state changes are needed in the child component, we don't have to do anything. For example, so this is our application and this is our products component, and here we are displaying one component, and there we are displaying another component, and there we are displaying another component, and this is where I want to display the count, right? And if this is where the list is being maintained, it is not big deal. It is not a big problem. Why? I can simply pass on it to the child components, and every time the state is changing in one component, automatically the children are re-rendered, and their children are re-rendered, and their children are re-rendered. So a state change in one component can very easily be recognized by that component and its children and their children and their children and their children. So if it has to flow from top to bottom, no issues. But the problem is, if it has to go from bottom to top, right, it is a major issue. You need to call back, and that can make our application very, very messy. That can make our application very, very difficult to manage in the long run. Am I making sense?
Yep.
Right? Okay. So how do we solve this problem? So now even before getting into the solution, right, what causes this issue? What causes this issue? Basically, the crux of this problem is when one component state changes, it has to be recognized in other parts of the application. When one component state changes, that change has to be recognized in other parts of the application. And unfortunately, the component state infrastructure is designed in such a way that when the state changes, it can recognize its change, and if the state is passed as props, its children can recognize it, and their children can recognize it, and their children can recognize it. That shouldn't be a problem. But recognizing the state changes outside that component, right, either in its sibling or somewhere in the hierarchy, right, recognizing the changes outside the component is extremely difficult. Why? For the simple reason that when you use the states, when you use the state in a component, right, you are localizing the data for that particular component. When you use the state infrastructure of a component, you are localizing the data for that component. So when you say localizing the data, what I mean is the changes to that state can be recognized by that component and their children. It is not straight away. It is not a easy way. There is no easy way to propagate those state changes, to recognize those state changes outside the component. So all you have to do is make sure that you don't localize the data for that particular component. If you don't localize the data, then it is possible for you to make the data available to other parts of the application.
If I should not localize the data, then why React gives me an infrastructure called state? If I'm not supposed to localize the data for that particular component, then why React gives me an infrastructure called state? Right? It should not be there. So why is it there? So the reason is that there are, when you take the state, we should recognize the state, we should categorize the state into two categories. Number one, the state that supports the core application logic, core logic of your application. Right? For example, products. If your application is all about managing products, then the product list, the products are the application state. Right? If you take Gmail, the emails are application state, the folders are application state, the labels are application state, the categories are application state. So the core, the data that supports the core business logic, those are what we call as the application state. The second category is the UI state, the data that supports the presentation aspects of the application. The data that supports the presentation aspects of the application. Okay, and how will I find out? How will I find out what is what? Very simple. The data that supports the presentation will not be needed outside that component. Or in other words, the change to this particular data is not needed to be recognized by other parts of the application. The change to this data, whenever this data changes, other parts of the application will not be interested in that particular change. Who will be interested? Only that component will be interested. So if you have the data whose change need to be recognized only by that component, and the change is not needed to be recognized in other parts of the application, then it is more likely that that data is there to serve the presentation needs of the application, the UI state. But if you have a data that supports the core application logic, there is a very high probability that the changes to that particular state has to be recognized and processed by other parts of the application. Or you can safely assume that the changes are to be processed throughout the application, through all the components, right? The changes that you make here has to be recognized through all the components in the application. Don't keep them in the component. So this, you can keep it in the component state. This, no component state, right? This should not be kept in the component state. Why? Because the data, when a change happens to this particular data, the changes cannot be directly recognized by other parts of the application. Whereas this data, it will not be recognized by other parts of the application, but I don't want to be recognized by other parts of the application. This is the data that is that is used for presentation and will be needed only for that particular component. Other parts of the application will not be interested in. So that data, you keep it in the component state, right? But if you have any data that is supporting the core application logic, don't keep it in the component state, keep it out. Am I making sense? So when you keep them out, then it becomes easy for you to propagate that state changes throughout the application. So how we do that, I'll explain. But is this clear? Any questions? Okay, all right. Guys, are you with me? Am I audible?
Yes.
Yep.
Okay. All right. So how do we solve the same problem? By not using the component state for the product lists, right? So in our case, what is your UI state? What is your application state? So what is that? When you look at this data, which data I want to be recognized, a change on that data should be recognized only by that component, and which data I don't want to be recognized by, I want to be recognized by all other parts of the application. So if you take this, right, you realize that the new product name, a change to new product name has to be recognized only by the products component, right? And Other parts of the application should need them only when you add them. Only when you click the button, it is needed, right? Other than that, until you click the button, no other part of the application is interested to know what is the new product name. Whereas what happens to product names is needed throughout the application, right? Is needed throughout the application. So what I will do, I am going to rewrite the same solution in such a way that the product names is kept outside and the new product name can be kept as a part of the component itself. But if you want, you can also keep that also outside. Okay. So how do I do that? I'll save this as 08 products using the model, right? Using the model. So let us create a products model to manage the application state. So class products collection, I'll call this as a products collection, extends event emitter. So why? Because we want it to be observable, right? So how can I make it observable? It has to let others know whenever it is undergoing changes. So let us create a simple event emitter, and this will have all the subscribers in an array, and then we will have a subscribe method, and this will take a callback function, and we will push that into that particular array. So if type of callback is equal to a function, then we will say underscore subscribers dot push the callback function, and then we will emit the change. So emit change is a method where we will simply call this dot underscore subscribers. This has to be this dot. So this dot underscore subscribers dot for each, take one callback at a time and call that callback, right? Okay, so this will manage the event subscribers and the logic for emitting change, and our products collection will maintain an event emitter. Okay, now here we will have a list. So underscore list equal to an array, and we'll have a get all method, and in the get all method you can say return a new array of this dot underscore list. Okay, and then we can have an add new method that will take the new product name, and what this will do, this will simply say this dot underscore list dot push the new product name, but we will let others know whenever it is changing. So what we can do, we will simply call this dot emit change, right? This dot emit change. So that now we have the collection model that manages the list of products, and it can let others know whenever it is changing. Okay, very good. Now how will I rewrite the products component? The products component will manage only the new product name. It will manage only the new product name, and this will be given with the model as a prop, right? The collection as a prop. So you take only the new product name from the state, and when the button is clicked, we will take it from the prop. One second. So comma and products collection is equal to this dot props, and all I have to do is, you don't have to do this, you simply call products collection dot add new of the new product name, products collection of add new of the new product name. That's it. Okay, so this is what all I have to do, and here I will get some data I will display, and in the app component, to the app component I can pass the collection. So constant products collection is equal to new, what is the name of it? Products collection. So products collection, right? Create a new instance and then pass it as props. So you can say model equal to the products collection, and then here we will wrap this inside a render app function, and now call render app once, and then products collection dot subscribe what, the render app function. And what this guy will do, he will not manage, he doesn't need to manage any state, he doesn't have to pass any callback, He doesn't have to do any of that. All he will do is he will take it from the props. So constant model is equal to this dot props, and then products count. He needs it, right? So count is equal to model dot get all dot length, and pass only the count here, and here you pass the whole collection. So products collection is equal to the model, right? Products collection is equal to the model. Now go back. This is 08 products hyphen model dot html. There is another error. Cannot read property map of undefined where products dot render. So in products dot render, okay. So this is this dot product props dot products collection dot get all dot map. Okay, so I have to break this, so that's okay for now. Go back, reload. Now I add pen, right? Pencil, marker. Okay, so what happens now? I have created a class, a model class that manages the list of products, and that is an observable. So I can recognize whenever it is changing, it will let us know, right? It will let us know. And then in the products component, it internally manages the new product name as a state. Why? Because a change to new product name is not needed to be recognized by other parts of the application until you click the button. So when you click the button, you take the new product name from the state, and then you are given with the collection as the props, and you simply call products collection dot add new, the new product name. That's all. And then in the main component, in the app component, from outside, I am passing an instance of the products collection, and I am subscribing to the products collection and say, hey boss, whenever you are changing, please re-render this whole app component. And here, this guy receives the props and then passes it wherever it is needed. Am I making sense?
Yep.
Yes.
Right? So I'm checking in this code. Take this, have a look at it. Okay, so this justifies the need for managing our own model, right? Why? Because changes to that model data might need to be recognized in throughout the other parts of the application, not only in that component and their children, but in other parts of the application as well. But if we have it in the state of that component, then the changes can be recognized only in that particular component. So we have to keep them out. Okay, very good. How will we keep them out? So we have created one model, an observable model, and that can let others know whenever it is changing. Okay, very good. But this observable model has its own limitations, right? Our implementation of the model has its own limitations. What are the limitations, right? So now let us expand the scope of this problem. Let us expand the scope of this problem. What is that I want to do? Okay, so let us expand the scope of this problem. What is a problem? Uh, what is that we want to do? Whenever I am displaying the new product, right? Whenever I'm creating the new product, so this dot, let me refactor this a little bit. So here I will say constant product names is equal to this dot props dot the collection, right? Product names, and I'll keep it here. Okay. Now, when I'm creating this list of products, I want to make it a little complicated. What is it? Each product will have a span slash a span, and then it will also have a button, type equal to button, type equal to a button, value equal to toggle out of stock. Okay, value equal to toggle out of stock. So whenever the button is clicked, okay, so let us see how it is getting displayed. Let's go to the browser, reload it, and say pen and pencil, etc. Right? So we get a toggle out of stock button, and whenever the button is clicked, we have to mark the product as out of stock. If it is already out of stock, if it is already in stock, when you click it, it should become out of stock. If it is out of stock, when you click the button, you have to mark it as in stock. Okay. Now, how will you differentiate it? How will you differentiate it? So maybe we will define a style. I'll say a style, and dot out of stock is color is red color, text decoration is line through, and font style is italic, and font weight is bold. Right, font weight is bold. So when I display, so just to show you, right, how it appears. So for the H1, I'll say class equal to out of stock. I'm simply applying the class, and when I reload this, you see, right? So this is how class name, right? So this is how out of stock products have to be displayed. So when I click the button, when the product is marked as out of stock, then this is how the product name has to be displayed. So this is problem statement number 1. Problem statement number 2, the count, what we display here, right? Products count. The count should not display only the count. The count has to display number of out of stock products by the total number of products. So here we have to display the number of out of stock products, and here we have to display the total number of products. Okay, and we will have one more span that displays a slash, so that we can see, right, how it is appeared. And this you can define it in the out of stock class name. Sorry, once again I'm forgetting it. So this is class name. So we have to display the number of out of stock products slash the total number of products. And whenever you add a new product, it has to be updated here. So by default, this will be 0. And this will keep incrementing whenever you add a product. When you toggle this, this has to increment or decrement. Am I making sense?
Yep.
Right? So I am checking in the code, take this, attempt it, see where it takes you. And I think it is already 1.5 hours. Maybe you can take a 15 minutes break and then come back, take a break and come back and solve this.
Sounds good.
Yep.
Oh, yeah. 15 minutes? Yeah. 15 minutes. Yeah, so we'll be back in about 15 minutes, okay?
Yep.
Cool. Okay.
Are you done? Or you are still doing it? Doing it? Okay, okay, okay. So what makes it difficult to implement that? So first of all, what we have to do, we have to make the product as a model, right? The product itself should become an object. Why? It cannot be a string, right? It cannot be a string. It has to be an object. Okay. So how do we make it as an object? Here is where we get the product name. Let's create a new product. So constant new product equal to an object with the name new product name, comma, is out of stock, right? I will make it as false by default. And then what will go in? The new product will be added to the array. Okay, very good. Now, when I want to display this product, this is where I want to display. So I will say this is, I will call this as products, and take one product and display the product dot name. And then we have to display this in two styles, right? So I'll say product dot is out of stock. If that is the case, then display this with class name is equal to out of stock. Right? Otherwise, display it without the class name. Okay. So this can be refactored, but I am going to write it as it is here. Okay. Now there is a button, and in this button we have to toggle it. Right? In this button we have to toggle it. So how will I toggle it? So this is question number 1. So I'll say on click is equal to this dot on product name click. So what am I going to do in on product name click? We will decide. Right? This we will decide. Okay, very good. And here in the products count, we get the data. So the data will be, let's assume that we are receiving all the products, right? So I'll say this is constant products equal to this dot props, and then out of stock count is equal to products dot reduce, take a result and one product at a time, and check if the product dot is out of stock, then plus result, otherwise return the result as it is starting from 0. And then we will display the out of stock count here and the products dot length here. Right? And the products dot length here, and we will display the products. Right? Model dot get all. So we don't have to pass the count, we are passing the whole products. Okay, very good. Now let's go to the browser, reload it. It is displaying 0, 0. So let me remove this style. It's a little ugly. Okay, so now this is displaying 0 out of 0, and let me add a product. So pen, pencil, and marker. Okay, so I'm adding these products. Now I need to toggle them, right? I need to toggle the out of stock. So how will I toggle the out of stock? Click the button. When I click the button, that product state has to undergo changes, right? That product state has to undergo changes. So first of all, how will I know which is the product that is being toggled? How will I know which is the product that is being toggled? We can pass the product as an argument to the event method. So event listener function. So pass the product, and here we can receive the product, and then I will say console.log the product is being toggled. Product comma is being toggled. Okay, so save this, go to the browser, reload it, and let's add a pen, let's add pencil, right? Let's add marker, And now click the button. It prints the product, the underlying product. Name pen is out of stock false is being toggled. Click the second one, pencil. Click the third one, marker. So we are able to recognize which is the product that we want to be toggled. So that much we have implemented. But how will we actually toggle the product? Can anyone guide me? Tell me the line number and tell me where we can implement this logic. Where can we write this logic? The actual toggling of the product. Where can I write this logic? Can I write it in the button click?
In the collection. No.
Yeah. So we can say product dot is out of stock is equal to not of product dot is out of stock. Okay, I can write this. Now let us say console.log what is the product. Console.log what is the product. So reload it, add a product and pencil, right, and marker. So total count is getting displayed. And now when I toggle this, the product is toggled, is out of stock is true, right? But this is not reflecting, the product name doesn't reflect that state. Similarly, when I click the next one, right, when I click the next one, it is saying name pencil out of stock false. Click it again, name pencil out of stock true. So this is not reflecting the change, and this is also not reflecting the change. Why?
You have to emit the change, call that emit change.
Call back where? Whom should I call? Whom should I let know that this product is changed?
Ultimately the collection, and then
Very good, right? So we have to let know the collection. Okay, very good. Now the question is, should this logic be in the component?
no.
No, right? So this itself is wrong. This should not be in the collection. So where should this logic be? This should not be in the component. I'm sorry. This should not be in the component. So this can be made as a part of the collection. Am I making sense?
Yeah.
Right? So what I will do, I will write this logic in the collection. So I'll say toggle, take a product, and here I will say product dot is out of stock is equal to not of product dot is out of stock. Okay, very good. And then I have to do one more thing. What is it? I have to let the view part know that some state change has happened. So I will call this dot emit change. Am I making sense? Right? So from here, what I have to do, I have to simply call the collection. So where is the collection? So you don't do that logic here. So we'll simply call the collection. So this dot props dot products collection dot toggle the given product. Okay, very good. This dot props dot products collection dot toggle the given product. Excellent. Now let's go to the browser, reload it, and let us check if this is working. So pen, pencil, and marker, add new, and click the toggle. Now this is working, right? The pen is marked as out of stock, and this shows a 1 out of 3. Now the pencil is marked out of stock. This shows 2 out of 3. And toggle out of stock, marker is marked as out of stock, and this shows 3 out of 3. Very good. We have implemented this solution, right? So first and foremost, the logic for toggling the product should not happen in the component, right? So that need to be clear. It has to happen outside the component. So where it can happen, in our case, we have implemented it in the products collection. We have implemented in the products collection in the toggle method. Okay, very good. Now this is working. But what I want to do is, I don't want this LI to be created as a part of the products component. I want this to be created as its own component, the product item component.
each li has to become its own component. So I will say class product item extends react dot component render, right? What is that I want to render? I want to return this li. I want to return this li. And where is the product? The product will be given as props. So constant product is equal to this dot props. Product equal to this dot props, and you display. Okay. Now where is the on product name click? We will have to get that also inside the product item component. So I'm taking this, I'm moving it in the product item component. And for now, I am going to put a console.log. So just say console.log of product. Console.log of product. Am I making sense? Okay. And then here, when I render this, I'm not going to render the whole stuff. I'm going to render the product item key equal to index. So you don't have to do any of this. Just say what is a product. So product is equal to the given product. Product equal to the given product. Okay, so I simply refactored the li into its own component called the product item component, and I pass the respective product as a prop, and I delegate the responsibility of displaying the product information to the product item component. Okay, now I have saved this. Go to the browser, reload it. Now I'll say pen. It throws an error. What is the error? Index is not defined. Okay. So here, this index has to go away, right? Save this, go to the browser, reload it. Now you say pen, pencil, marker. Okay, very good. Now, when I click the button, I am able to recognize which product is being toggled. Now, how will I toggle it? From product item, how will I toggle it? Right? You cannot directly toggle it. You can say product dot is out of stock is equal to not of product dot is out of stock. You can write this, nothing wrong. I mean, nothing stops you, but this is non-UI logic in the component, in the UI part of the application, right? So this you cannot write it in the component. Then where should we write this? This is anyway implemented in the collection, but the question is, does product item have access to the collection? The products component has access to the collection. The products component has access to the collection, but the product item doesn't have access to the collection. The child component does not have access to the collection. But the child component has to toggle the product. How will we do this? Right? So let me put it here. So here is the products component. Here is the individual product component, 1, 2, 3, etc. And here is our collection. Here is our collection, and we have one product and another product. Okay, and here is our render app function. So this is our render app function. Now let us take problem number one. What is it? Adding a new product. Adding a new product. So when we wanted to add a new product, this component collected the data. So this guy, the outer component collected the data, and he called the add new method on the collection. He called the add new method on the collection, and the product was added, and we called the render app, and the render app re-rendered the component. So we saw the complete changes. So this is with respect to add new, when we wanted to add a new product. But when we wanted to toggle a product, right, initially the communication happened between the products component and the collection itself. So directly we called this
So we were able to toggle, and when it toggled automatically, we were able to call the render app, and we were able to re-render the whole application. We saw the changes. But now what we want, we don't want to toggle from the products component, from the outer component. We don't want to do it from the outer component. We want to initiate that process from the inner component. We want to initiate this process from the inner component. Now the inner component do not have access to the collection. Right? Now if it doesn't have access to the collection, what are our choices? Choice number 1. Guys, are you following? Do you understand what I'm trying to say here?
Yep.
Right? Okay. So choice number 1 is the parent component can give the reference of the products collection as props. It can send the reference of the products collection as props to the child component, right? And it can ask the product item component to call the toggle method, right? So this will work. For example, I can say this dot props dot products collection dot toggle the given product. And how will it have access to the products collection? In the product item, when you are creating a new instance of the product item, you not only pass the product, you also have to pass the products collection. So you say products collection is equal to this dot props dot products collection, right? So you can do this. Nothing stops you from doing it. Now let us go to the browser, reload it, add the pen and pencil and marker, right? And toggle it. Now this is working. 1 out of 3, 2 out of 3, 3 out of 3. This is working. But the question is, should the product item know about the whole collection?
Sorry, could you not just pass the on-click method instead of the products collection?
Very right. Now, so now is this clear? So I'll come to that bit, right? Okay. So we should not pass the whole collection to the product item. Why do we have to pass the whole collection to the product item? We should not pass the whole collection to the product item. Okay, very good. Now what is the other choice? Now as Pete said, what we can do? The product item component, this component, when it is being clicked, it can call the parent component and say, hey boss, my product is clicked. Now you call the collection and tell him to toggle the product. Right? You call the collection and tell him to toggle the product. So I can very well do that. Nothing stops you from doing it. So from the product item component, you can call the parent component and say, hey boss, my product is being toggled. You do what need to be done, you please do. And the parent component has access to the products collection. So it can call the products collection and say, toggle this, and automatically it will be toggled. Okay, no issues. But now the problem is, what if the product item is not a direct child of this parent component? There are multiple levels. So you have the parent component, and the parent component has a product list component that has one more component, and there we display the product item component. Now what should happen? The communication, the click event has to be propagated from the component to its parent and its parent and its parent. So it has to keep travel. That instruction has to travel from the innermost component to the outermost component through all the levels. Communication in the reverse direction should happen. And the problem with communication in the reverse direction is, if there are multiple levels, then your code will get more and more complicated. Is that clear, Pete? You understand what I'm trying to say here?
Yep, certainly. Yep.
Yep. Okay, good. Now what else is a choice? Now here we can assume that the problem exists because we have the toggle method in the collection. The problem exists because we have the toggle method in the collection. But instead of having the toggle method in the collection, why can't we have the toggle method in the individual product object? Why can't we have the toggle method in the individual product object? So if we have to do that, right, then how it will become? So I'll show you. So here is our products component, and here is our individual product item component. Here is our collection, and here is our individual product object, right? So when you talked about add new, so from here we call the add new, and this resulted in the render app function, and that re-rendered the component. Okay. Now I am going to implement the toggle method right here in the individual object, the product object, right? Now, when the button is clicked, when here you are clicking the button, this directly has access to the product object. So this can call the product object and say, boss toggle, right? This can call the product object and say, boss toggle. It can toggle, but your application will not be re-rendered. Why? Who is subscribing to the render app? Only the products collection is subscribing to the render app. So when the products collection is changing, you can render the whole application. But when the individual product in the collection is changing by default, the products collection cannot recognize that change, so that it can call emit change. It cannot recognize that particular change. So what need to be done now? Now the product component, whenever it is toggled, it has to call the collection and say, hey boss, my state is changed. Please call the render app so that the whole component tree can be rendered, and this will in turn call the render app. Am I making sense? Right? So now when we have one single entity, when we have just one single entity, product, you are displaying that particular product, or a collection and you are displaying that particular collection. So when you have one single entity or one collection, no issues. Our model implementation will work. But when the UI grows more deeper, right? You create multiple hierarchies at the UI level, or when your model grows more deeper, right? So here we have products, but what if we have a hierarchy, like we have an organization, right? And the organization has multiple categories of products, and each category has multiple products. So when the hierarchy grows either at the UI level or at the model level, right, we cannot avoid reverse communication. So either the reverse communication should happen at the UI level, or the reverse communication should happen at the model level. And the problem with reverse communication is, when the hierarchy becomes more and more deeper, it will be very difficult to implement. It will be very difficult to trace, right, where the state changes in your application, and your application will become extremely difficult to maintain in the long run. You understand this problem? It is very important we understand this problem, so that we can better appreciate the solution. We can understand the solution. Does everyone understand the problem, or do I have to explain again?
Oh, yeah, good for me.
We are good? Okay. Now why is this? Why do we have this problem only in React? Why do we don't have this in other frameworks? Is this problem unique to React? Right? Kind of, yes. This problem is kind of unique to React. Why? For example, the reason is, I told you yesterday, React follows an all-in-one approach. So anytime anything changes, you have to re-render everything from top to bottom. The state change happening in one part of the application has to be recognized in other parts of the application, and to do that, the whole component tree has to be re-rendered from top to bottom. In other frameworks, you follow an incremental approach. You locate a particular DOM node and you make changes. Whenever the state is changing, you locate a particular DOM node and make changes. Whereas React follows an all-in-one approach. So everything has to be rendered from top to bottom. You have to re-render everything from top to bottom, right? So because of this unique challenge comes in. This unique problem comes in. Okay. So what is the solution? Right?
Now, our model implementation is limiting because we are following a true OO design, right? Because we are following a true OO design to create the model. So what do I mean by OO design for creating the model? In object-oriented design, right? What is a fundamental idea behind object-oriented design? You create objects which encapsulate the state and behavior, right? You create objects that encapsulate the state and the behavior. You create one object that has its own state and behavior, right? So this is how we created our model infrastructure. This is how we created our model infrastructure. So let me let prove this, right? So if you take the products collection, you take the products collection. The products collection, so this is our collection. The products collection, what is the state in the products collection? The array is the state in the products collection. And what is the behavior? Add new is the behavior. Right? Now, if you take the product object, one single product object, right? What is the state? The state is the name is the one state and is out of stock is another state, right? And what is the behavior? Toggle is the behavior, right? So we try to create our model based on the true object-oriented design, right? This has a limitation. What is the limitation? State changes need to be recognized throughout the application, right? And when in a collection, if one object is changing, it has to call the parent and say it has changed, and it has to call its parent and say it has changed, so that the whole UI can be re-rendered. So you have to do a lot of reverse communication. Okay. Now, in functional languages, right, you don't have to keep the state and behavior together. In functional languages, you don't have to keep the state and behavior together. We don't have to create an object. We can keep the state and behavior separately, and depending on our need, we can apply the behavior on the state. Right? You can keep the state separately. You can keep the state separately. Right? And you can keep the behavior separately. And depending on the need, I can take the behavior and operate on the state. I don't have to keep the state and behavior together. I don't have to do that. I can keep the state separately, behavior separately, and depending on the need, I can apply the behavior on the state. You will find this model of application design being followed in almost all functional languages. You take Scala, right? That is what we do. In Scala, your data is accumulated and your data is maintained in case classes. What are case classes? Case classes are plain simple data containers, right? And your behaviors are implemented as plain simple functions. And whenever we want, we take the function and apply on the state, right? So almost all functional languages follow this approach. And JavaScript, to some extent, is also a functional language, right? It is not a pure functional language, but it has a lot of aspects of the functional language applicable to it. So how do I say so? Let us take, for example, if I have a function, okay, let's say I have an object, emp equal to an object, where I say name is Magesh, right? And I have a behavior. So who am I, right? We discussed about this yesterday. And I'll say console.log, I am, comma, this dot name. Now, I want to execute who am I in such a way that it prints I am Magesh. So how can I do that? Very simple. Usually in object-oriented language, you will say emp dot who am I, object exhibiting a behavior, right? Whereas in functional language, you don't have to do that. What you can do? You can take the behavior who am I, and you can say execute with the context of that object. It prints what? I am Pravesh. Now, what is the benefit of this? I can have the behavior available to other objects as well. For example, if I have a product where I can say name is pen. Now I can say who am I dot call of the product object. It will say I am pen. Right? Let's expand the scope of this a little bit. What is it? Let's say I have an array, right? So numbers equal to 3, 1, 4, 2, 5, right? And I want all the values except the first one. I want all the values except the first one. So I can say numbers dot slice of 1. Okay, very good. It gives you all the values except the first one. But let's assume that I have an object where 0 is 10, 1 is 20, and 2 is 30, 3 is 40, right? And length is 4. Now, I want all the values from the object except the first one. I want all the values except the first one. So can I say obj.slice of 1? It will throw an error. It will say, boss, you don't have the slice method. What is the solution? The solution is you can take the behavior and apply on the state, right? So what I will do, I don't have to recreate, convert, I don't have to do the type conversion because JavaScript is loosely typed. I don't have to do the type conversion, and JavaScript is functional, so I can take the behavior and apply on the state. So what I will do, I will take the array method, borrow the slice method from the, array object. From the array object, borrow the slice method and make it operate on the given object with an argument 1. It will give you 20, 30, 40. As a matter of fact, the slice method itself does not belong to the actual object. It is borrowed from the base object, the prototype, right? So if you look at the console.dar of numbers array, you'll find that the numbers array has only the values 0, 1, 2, 3 and the length attribute. Where is the slice method coming from? The slice method is coming from the prototype, the base object. So what is the prototype of array? Array.prototype. So I don't even have to use the numbers array. What I can do, I can simply call array.prototype.slice.call of the given object, comma 1. Now this will still work for me. Right? So as long as the slice method's expectations are met by the given object, the slice method will be able to act on that particular object. The slice function will be able to operate on that particular data. Right? So this is what I meant when I said you can keep the state separately, behavior separately, and depending on the need, you can apply the behavior on the state. Depending on the need, you can apply the behavior on the state. Right? Now, this is a simple idea. And we are going to extrapolate this idea for the whole application. We are going to extrapolate this idea for the whole application, right? Now, remember, the fundamental problem that we have here is we have to recognize the state changes. We should be able to recognize the state changes so that we can re-render the whole application from top to bottom, right? And we find it difficult to do because the state is scattered across multiple objects. So you have a collection, this has its own state, and we have individual objects, they have their own state, and probably, right, you will have one more collection that will have some objects, and they will have reference to something else, and that will have some objects. So if each of them change individually, if each of them change in their own way, right, it may be very difficult for us to recognize what is changing when is changing, right? So what we are going to do, we are going to apply what we learned just now. What is it? Keep the state separately, behavior separately, and depending on the need, apply the behavior on the state. We are going to extrapolate this for the whole application. For the whole application. How am I going to extrapolate this for the whole application, right? So people tried different approaches and finally they concluded on one particular way of solving this problem. What is it? Number one, in your application, you are not going to scatter the state across multiple model objects. We are not going to scatter the state across multiple model objects.
So then what are we going to do? We are going to have one object where we will manage the states. We are going to have one object where we are going to manage the state. One object for the whole application. One object for the whole application. So in your application, you might have orders, you might have customers, you might have products, you might have vendors, suppliers. It doesn't matter. If some data is not kept in the component state, that data has to go to this object. If some data is not maintained in the component state, that data has to go to this object. So what is this object? This object is what we call as a store. Right? So we are going to have one single object for the whole application where we will maintain all the application state. Any data that does not make into the component state will be maintained in this particular object. Okay, very good. Now, I want to display the state. So how will I have access to the state? I want to display the state. So how will I have access to the state? So this object, it will expose a method called getState. So using the getState method, you can gain access to the underlying state, right? Using the getState method, you can gain access to the underlying state. Okay, very good. So you take the state and you display. Very good. Now, why are we consolidating all the data in one particular object? Because we want to have a single point of contact to know when any state is changing. If we have the state scattered across multiple objects, then it becomes difficult for us to know when any of the state is changing. That is why we are keeping all the state in one place, right? So the main reason why we keep the state, the whole application state in the store object is that we want to have a single point of contact to know when the state is changing. We want to have a single point of contact to know when the state is changing. Okay, how will we know when the state is changing? So the store object will also expose a subscribe method to which you give a callback function, and automatically the store will take the responsibility of calling you a callback function whenever the state is undergoing changes. Okay, so the store has two methods as of now. One is getState, the other one is subscribe. GetState is how you can gain access to the state. Subscribe is how you can subscribe for changes. So anytime the state is changing, your callback function given through the subscribe method will be invoked whenever the state is changing. Okay, very good. Now, where am I going to write the logic for state changes? The logic for state changes, how the state is going to change. Where am I going to write the logic, right? That logic is implemented as a function. That logic is implemented as a function. Okay, so what is this function? This function is what we call as a reducer function. This function is what we call as a reducer function. Okay, so why is it called as a reducer function? Why is it called as a reducer function? I'll explain. So as I said earlier, the state changes are going to go here, right? All the state change logic is going to go here. Okay, very good. Now, if this has to change the state, right? First of all, the function has to have access to the state. How will the function have access to the state? See, the store has a getState method using which it can have access to the state. Okay, fine, no problem. So the reducer can call the store's getState method, get the state, manipulate it. Okay, it manipulates it. But then the changes have to be updated in the store, isn't it? The changes have to be updated in the store. So how the changes can be updated in the store? As of now, the store has only two methods, a getter and a subscribe method. There is no setter method. There is no method for setting the state. There is no method for setting the state, right? So if there is no method for setting the state, how will the reducer update the state changes in the store? Right? So what we need? we need a setter method, right? Let's assume that we need a setter method. So let's assume that we have a set state method. So this has a set state method. And using the set state method, the reducer can update the state. Okay, but there is a minor problem, not a minor problem, there is a major problem. What is the problem? The problem is any state change should happen only through the reducer. Thus, no one should be able to change the state bypassing the reducer. No one should be able to change the state bypassing the reducer, right? Let us take a simple example. You have a bank account. So what is the state in the bank account, in your bank account? The balance is a state. The balance, how much money you have in your account, right? The balance is a state. Now, how the balance will change? The balance, can you directly open your bank account and change the balance manually? You cannot change the balance. The balance can change only through two operations. Either you deposit some money or you withdraw some money. That is how the state change must happen. You should not be allowed to directly change the balance, right? So apply the same concept here. If you have a set state method in the store, then what can happen? Anyone can directly write a new state into the store bypassing the reducer, and that should not be allowed, right? So the set state is a bad idea. You cannot have the set state method. If you have the set state method, then anyone can change the state bypassing the reducer. So there cannot be a set state method. Okay. If the set state is not there, then how will the reducer act on the state? So till now, we have been discussing the communication is, the communication strategy where the reducer is calling the store, getting the state, etc. Right? But that requires the store to have a set state method. So instead, what we are going to do, we are going to inverse that relationship. What is the relationship? The store is going to call the reducer. The reducer is not going to call the store. The store is going to call the reducer. And what it will do, it will call the reducer and say, hey boss, this is my current state. Can you please act on it and let me know what is the new state? Right? The store will call the reducer and say, boss, this is my current state, right? This will come in here. So this is my current state, and can you please act on it and let me know what is the new state? And what the reducer function will do is it will either return, right? It will either return a new state if it can change the state, or the current state as it is if it doesn't know how to change the state. Okay, the reducer function will return either the new state or the current state depending on whether it is able to change the state or not. If it is able to change the state, it will return the new state. If it is unable to change the state, it will return the current state. Now what the store will do? The store, once it calls the reducer giving the current state, it will wait for the reducer to return the data. If the reducer returns a new state, it will update it and it will call the subscriber. If the reducer returns the current state as it is, it will not do anything. Okay. Now the question is, on what basis the reducer will know what it has to do, whether it can change the state or not, right? On what basis? For example, if you take our own application, right? How the state change happens? The state change happens through user interaction. The user wants to add a new product. The user wants to toggle a product. The user wants to remove a product, right? So the state change happens because of external events occurring in your application, the actions performed by the user. So what we have to do, we have to call the reducer store and say, boss, this is an action happened. Now you do your job, right? So how do you do that? You call this, the reducer, the store also has a dispatch method to which you pass an action as an argument. And when you call the dispatch method with the action object, action indicating what action need to be performed, the store will call the reducer with the current state and the action, right? So let me clear this off. So it will call the reducer with the current state and the action. So there are two arguments passed to the reducer, and what the reducer will do, it will either return the new state or the current state as it is. On what basis? If the reducer can perform the action, it will return the new state. If the reducer cannot perform the action, it will return the given state as it is. Right? Very basic idea, nothing very complex. So let me reiterate once again. We are going to have one single object to manage the whole application state. For the whole application, any data that does not make into the component state will be maintained in this particular object. So this object is what we call as the store. And it is going to manage the whole application state. And I want to render this particular state. I want to show this data to the user. So in order to facilitate that, the store has a method called getState, using which you can gain access to the underlying state and display that data to the user. The whole purpose of having a store object is to know when the state is undergoing changes. We want to have a single point of contact to know when the state is undergoing changes. So how will the store let us know when the state is changing? We have to subscribe. So it also exposes, the store also exposes a subscribe method to which you give a callback function, and that callback function will automatically be executed every time the state is undergoing changes in the store. Okay, fine. But now, who will change the state? Who has the knowledge to change the state? That knowledge will be in as a reducer. The reducer knows how to change the state. So it is just a function. A reducer is basically just a function. And the reducer will be invoked with two arguments. One is the current state, the other one is the action. And what the reducer will do? The reducer, based on the action, if it can perform that particular operation, if it can change the state, it will change the state and return the new state. If it cannot perform the operation, it will return the current state as it is. And when the store calls the reducer with the current state and the action, depending on the result, the store will react. How it will react? If the reducer is returning a new state, then the store will update the state and it will call the subscriber and say, boss, things have changed. But if the reducer is returning the current state as it is, the store will simply ignore it. The store will not do anything. It will simply ignore it. Okay. Now this is a setup. Now when is the store to the reducer communication is going to happen? Only when the user interacts. So when the user is interacting it, how are you going to pass on that message to the store saying that this is what the user wanted, right? You dispatch an action. You dispatch an action. You call the store's dispatch method and say, boss, this is what the action performed by the user. You deal with it. And the store will in turn call the reducer, wait for the return result from the reducer. If the reducer returns the new state, it will update the state and call the subscriber. If the reducer returns the current state, it will not do anything. It will simply ignore. Right? So this is the fundamental idea. So this is made of two main parts. One is the store that manages the state. The other is the reducer that has the logic for changing the state. Is it clear?
Yep.
Everyone, should I have to explain it again? Are we good?
Yep, all good.
Okay, very good. Now, if you look at the relationship between the store and the reducer, the reducer is an existential dependency for the store. The reducer is an existential dependency for the store. So what do you mean by existential dependency? Without a reducer,
there is no meaning for the store to exist. Without the reducer, there is no meaning for the store to exist. Why? Think about it. We are creating a store to have a single point of contact to know when the state is changing. We are creating a store to have a single point of contact to know when the state is changing. And who knows how to change the state? Only the reducer knows how to change the state. So if the reducer is not there, the state is never going to change. If the state is never going to change, I don't need a store. You get the idea, right? Right? We want the store because we want to have a single point of contact to know when the state is changing. And who knows how to change the state? Only the reducer knows how to change the state. And if the reducer is not there, the state is never going to change. If the state is never going to change, I don't need a store. I don't need a store, right? So in order for you to create a store, there has to be minimum of one reducer, right? In order to create a store, there has to be minimum of one reducer. So how do we enforce this? How do we enforce this, saying that without one reducer, you should not be able to create a store, right? So what we do, we expose a factory method, and using the factory method, we are going to enforce that the store can be created only using a reducer, only when you have a reducer. So that factory method is called as create store, right? And what that will take? That will take a reducer as an argument, and which will in turn return the store. Okay. So now we are going to implement this whole infrastructure. Okay, so we will write our own code for creating the store, for get state method, subscribe method, dispatch method. So all these things we will implement this on our own so that we understand what happens in the scene. Okay, so let me write the code, and there are a few more details that are left behind, and we will discuss about those details as we go by. So I am going to create a new folder called as state manager. Okay, so 0 as a state manager.js. So this is where I am going to implement the whole logic. Okay, state manager. Why am I calling it as a state manager? Because this infrastructure is meant to manage the state for the application, right? So I am going to call it as a state manager. And what all we need? Let us think about it, right? This is very crude implementation. Okay, this is only for learning purpose. Whatever we do, don't even think about using it in your application. This is only for learning purpose. Okay. What is the role of the state manager? It has to manage the current state. So I'll say where underscore current state is equal to, by default, I'll give it as undefined. Okay, and we have to let others know what is the current state. So how? There is a method called the get state method. So let us write the implementation for the get state method. Get state, we will return underscore current state. Okay, very good, no problem. And as I said earlier, the whole purpose of this is to have a single point of contact to know when the state is changing. So how will we know when the state is changing? We have to subscribe. So we'll subscribe, pass a callback function, and we'll say underscore if type of callback is equal to a function, then we will call underscore callbacks dot push what? The given callback function. So what is the callbacks? So this is command underscore callbacks equal to an empty array. Okay, very good. Now, why do we maintain the callback? Because we want to let others know when things are changing. So function emit change will have an emit change method, and we will iterate through all the callbacks. Dot for each, take a callback and call the callback. Okay, very good. Right? Now, what else I want?
get state is there, subscribe is there. I also need a dispatch. So let us create a dispatch method. What will this take? This will take an action as an argument. And what do we want to do with this? We will call the reducer. Where is the reducer? Let us define a variable. So underscore reducer equal to undefined or null or whatever it is. Okay. And here we are going to assume that the reducer exists. So I am going to call the reducer with the current state and the action. I'm going to call the reducer with the current state and the action, and I'm expecting it to return a new state. I'm expecting it to return a new state. But is it truly new state, or the reducer has returned the current state as it is, right? We want to know. So we will check if the new state is equal to the current state, what we already have. Don't do anything because there is no state change whatsoever. We will simply return. Otherwise, underscore current state equal to the new state, and then we will call what? Emit change. We'll call emit change and say that, hey boss, things have changed. Now you do what you are supposed to do. Okay, very good. Now here, these are all individual functions. We need to put them as an object and return. So who will do that? We will have a function called create store. And what this will do, this will take the reducer and we will say underscore reducer equal to the given reducer. And then we will return an object. That object will have references to get state method, subscribe method, and dispatch method, right? So this is basically the store object. So if you want, you can create it. So where store is equal to this object and simply return the store. Now, out of all this, we want only the create store API to be exposed to the outside world. So let us have where state manager is equal to and immediately invoke function expression, wrap this whole stuff inside this function and invoke it. And here return an object that has reference to create store. Right? That's all. So now when this code is executed, you will have a top level object called state manager that will have a method called create store. You call the create store method with the reducer. You will get a store object, and for that particular store object, you can get the state using the get state. You can subscribe for the state changes using the subscribe method. And when the user interacts with your application, you can dispatch an action that will trigger the state change process in your application. Am I making sense?
Yes.
Yeah.
I'm checking in the code. Take this, have a look at it, and let me know. Are we good? Okay, very good. Now, there is one minor detail. What is a minor detail here? Let us say you are creating a store for a very simple application. Okay, let's say you are creating a store for a very basic application. You are yet to perform any action. You are yet to perform any action. And when you are yet to perform any action, what will be the current state? As per our implementation, look at the code and tell me what will be the current state.
Undefined.
Undefined, right? It will be undefined. Now, can undefined be a valid current state? Do you want to start your application with undefined as a current state, right? So every problem you want to solve would want to have a default starting point, a valid starting point. For example, you take a calculator, a normal calculator, digital calculator, right? You take a calculator, power it on, you are yet to add a number, you are yet to subtract any numbers, but you just power it on. What do you see? You see 0 because you want to start from 0. Right? So for a calculator, the default starting point, the default current state, the valid current state, initial state, you want to start from 0. If you take our products application, right, we are yet to add a product, we are yet to toggle a particular product, we are yet to remove a product, but still, when I want to start the application, I want to start the application with an empty array. The valid current state, I want to start with an empty array. Right? So, unfortunately, our implementation doesn't have the facility to initialize the current state with a valid state. Right? Our implementation assumes that the default starting point of your application, the default current state, will be undefined, which may not be the right decision. So we have to give the flexibility to the user of our library, our state manager library. We need to give the flexibility to decide what should be the valid current state. Where do we want to start? Right? So how are we going to give that? How are we going to offer that particular functionality? We have not considered the case of multiple reducers, right? So we are considering only one reducer, but in our application, definitely there will be many reducers. So each reducer might want to have its own current state. So who can be responsible for initializing the current state? We are going to delegate that responsibility to the reducer itself. So we are going to tell the reducer, hey boss, you tell me what do you want the default starting point. Before even an action is dispatched, you tell me what do you want the default starting point of your application. For you, what should be the default current state? Okay. So the reducer is going to be called twice. In our application, there are two circumstances when the reducer are going to be called. Number one is when the application is initialized. The reducer will be immediately called when the store is being created. The reducer will be called to initialize the current state with a valid starting point. And then subsequently, whenever an action is dispatched, we are going to call the reducer. Subsequently, whenever an action is dispatched, we are going to call the reducer. So these are the two circumstances when our reducer is going to be called. But in our implementation, we have done it only once. What is it? Only when an action is dispatched. But that is not sufficient. We have to call the reducer to initialize the current state with the default valid state, right? So how do we do that? What I will do, when the store is created, we get the reference of the reducer, but then with that, let us also initialize the current state. So current state equal to call the reducer with whatever current state that we have, right? And a dummy action, okay, very basic action to let the reducer know that we are calling it for initialization purpose. So I call this as underscore init underscore action. Okay, and what is this? Say this is for our application. This has got nothing to do with the user, so this can be anything. Now, when you look at the action, right, we are using an object. So your actions can be strings, your action can be numbers, your actions can be anything, but I am using an object here because that's a convention. Okay, so every action is an object that has an attribute called type, and the type will have a unique value indicating what is the action that you want to perform, right? So we'll discuss more about this. At this point of time, I am keeping the action as an object with the type as init underscore action. Okay, very good. Now let us put this into practice, right? Let us use this infrastructure to solve a very, very basic problem. Okay, so what is that problem? I'll explain. So create a new file, save it as index.html. So HTML:5 state manager. Okay, so script colon source. What is it? State manager .js. Okay, very simple. Nothing complex here. Just a plain simple HTML page where we have reference to the JavaScript file. We have a reference to the JavaScript file. And now let me open this page in the browser. Let me open this page in the browser. So index.html, drag and drop it. So nothing is here, just says a H1 state manager. But because we added a reference to the state manager, right, we have a top level object called state manager. We have a top level object called state manager that has a method called create store, right? That has a method called create store. So if I want to experiment with this infrastructure, I need to create a store. And in order to create a store, right, if I take the state manager.create store, it takes what? It expects a reducer. It expects a reducer. So without a reducer, I cannot create a store. Without a reducer, I cannot create a store. So first of all, we need to find a problem to create a reducer, and then create a reducer, and then create the store, and then dispatch an action and see how the state is changing, right? So to do that, what problem shall we take? To do that, what problem shall we take? Let us take the salary calculator example, right? For a different reason. I'll explain what it is. So let us take the salary calculator. And if you look at the text box, right? If you look at the text box is made of an up arrow, down arrow, right? And it is displaying a value. The text box is displaying a value. So when you click the up button, whenever you click the up button, right, the value is incremented and displayed. Whenever you click the down button, the value is decremented and displayed. Now, what is the state here? This number is the state. What are the action? Increment is one action. Decrement is another action. Am I making sense? Are you with me? So this gives you only the UI. There's a text box that gives you only the UI where the user can click the button, up button, down button, increment button, decrement button, he can do it. But internally, somewhere we need to manage this data. Somewhere we need to write the logic for what need to happen when the increment button is clicked, what need to happen when the decrement button is clicked, right? So that logic we are going to maintain as a part of state manager. That we are going to implement as a part of state manager. Okay, so that is now what I will do. I have to create a reducer. So what is the role of the reducer? The reducer should take care of state change logic, right? So how the state changes should happen. So here the reducer is a function. So I'll call this as a spinner, right? Spinner having up and down actions. So function spinner reducer. What should be the signature for the reducer? The signature for the reducer is it should take the current state as the first argument and an action as a second argument. What is it supposed to return? Now, we learned earlier that the reducer is called under two circumstances. What is it? When you create the store, the reducer is immediately called to initialize the current state with the default valid state. And then every time an action is dispatched, the reducer is called, right? Again and again and again. So if you look at our logic, when you create the store, we call the reducer. When an action is dispatched, we call the reducer. So these are the two circumstances when the reducer is called. But when you create the store, right, the reason for calling the reducer is completely different. What is it? We call the reducer to initialize the current state with a valid state, valid initial state, right? So how will we know when the reducer is being called to initialize the current state with a valid state? The current state will be undefined. See, when this call is made, what is underscore current state? The underscore current state will be undefined. So what I will do, I'll write the logic as if type of current state is equal to undefined, then what do you want to start with, right? I want to start with 0. I want to start with 0. So this is the starting point of our application. How else I can simplify writing this? How else I can simplify writing this? Current state equal to undefined, then 0. So what I can do, I will use the default arguments feature in ESX, and I'll say current state is equal to 0. Initialize it with 0, right? So if the current state is undefined, it will take the 0 value, and I don't have to write this if condition. We'll simply return the current state. So we'll say return the current state. Don't forget, we return the current state. And then we have to write the logic for the action. So what need to happen if the action is dispatched, right? What need, right? So we need to write the logic for the action. So we'll check if action is an object with an attribute type, right? So we'll say if action.type is equal to up or increment, right? You can say whatever you want. What we will do, we will return ++ current state. If the action.type equal to down, then we will return - current state. Otherwise, we simply return the current state. So this will be executed under two circumstances. What are they? If the current state is undefined, this will be returned. If the action is neither up nor down, then this will be returned. Okay, very good. So we have the reducer now. We have the reducer. Now, we need to create a store. So let us create the store where store equal to state manager dot create store with this spinner reducer. Okay, very good. We call it. Now what should have happened? It should have called the reducer. It should have called the reducer to know what is the initial state, and our reducer would have returned to 0, right? Let us check. We will call the store dot get state. What does it returns? It returns 0. Basically, the reducer, the current state is initialized to 0. Okay, very good. Now, I want to perform an action, right? So how do you perform an action? We have to dispatch an action. We have to call the store and call the dispatch method and say, this is the action that I want you to perform. So we'll say store.dispatch. Store.dispatch. What is the syntax for the action? The action must be an object with a type attribute. So we'll say type has to be what? Up. Type is up. Or what you can do, you can take this action object and keep it in a variable. So we'll say where up action is equal to an object with type is up, and then I want to dispatch the type action, up action, sorry. So store dot dispatch the up action. Very good, I have done it. Now what should have happened? The store should have called the reducer and say that, hey, the user wants to dispatch this action. Here is my current state. Here is the action. Please manipulate it and return the new state. And thereby, the store would have updated the current state. Has it updated? Let us check. So we'll call store.getState. What does it return? It returns 1. Earlier it returned 0. Now it returns 1. Now dispatch once again up action and then store.getState. It is returning 2. Right? Now I don't want to call getState again and again and again. I want the store to let me know whenever the state is changing. I want the store to let me know whenever the state is changing. So how do I do that? I will just store. So store.subscribe and the function use a single background. Right? So this is our subscription function. Now you keep dispatching the action. Dispatch up action, it is displaying current state is 3. Dispatch up action, it is displaying current state is 4. Now let us create a down action where down action is equal to an object with type is down. Right? Now you call store.dispatch down action. Now what is the state? Earlier the current state was 4. Now it is 3. Call it again. Now it is 2. Call it again. 1. Call it again. 0. Call it again. -1. What if you pass an action that does not have that the reducer doesn't recognize? So you pass an object where type is dummy. Right? Type is dummy. Now nothing will happen because the reducer doesn't know how to perform it. So it would have returned the current state as it is, and because it returned the current state as it is, the store would understand that there is no state changes, and because there are no state changes, it will simply ignore. Right? Very basic idea, very simple idea. We implemented. Now what we have to do? We have to write a UI for this functionality. Right? We need to create a UI for this functionality. So how will I create a UI for this? So let me take this whole stuff and then keep it here. Okay, so this is for your reference. Right? So this is for your reference. So all the undefined, get rid of it. Okay, so you can try these things when you come back from lunch. But then you try these things in the console and see how it works. One line after another line, you see how it works. And then what I want you to do, I want you to create a UI for this. What is a UI? The UI will be something like this. So it will have spinner and HR and input : button, value equal to down, and then plus a span where we will display the actual number, and then another button where we will display value equal to up. Right? You need to make this UI created in React. You need to convert this into a React component, and it has to collaborate with this infrastructure. it has to collaborate with this infrastructure so that it displays the actual value here. 0, 1, 2, 3 will be displayed here. When you click the up button, it has to be incremented and displayed here. When you click the down button, it has to be decremented and displayed here. You understand the problem?
Yep.
Yep.
All right, good. So break for lunch, be back after 1 hour, take 20 minutes and attempt this. Okay, so I'll touch base with you after 1 hour, 20 minutes.
Okay, thank you.
Thank you.
Hey guys, I will pause the recording now for now and restart in an hour.